All right, guys, welcome to a new unit now. We're in Chapter 6, Linear Algebra. And so right when we came off of the break there and then came into doing this stuff online, these are the last unit and this unit are the two most important things that you need to learn for grade 10. So especially if you're going into Math 10C ever, this is going to be about 30% to 45% of your entire grade is this particular chapter, and this chapter is just like the intro to what's about to come. So it's called linear algebra and or linear relations, and everything has to do with the word linear, which actually means a straight line. And so you'll notice in this graph here that this is a straight line. So in grade 9 we only deal with straight lines, but once you get into grade 11 and 12 you start to deal with things like parabolas, which are graphs that go kind of like that in a nice U shape, and into quadratics and different things which can have different shapes and different functions like that. So we're dealing with lines, so that's why we call them linear relations. So you'll see here that it's a straight line when it's graphed. And so what would happen here is when you go back to grade 7, if you remember, you always have the x-axis and the y-axis. And so before we even start here, I want to make sure that you remember that the bottom is always called the x-axis, all right? And that the line that goes up here is called the y-axis. That's going to be really important for this unit. So x is always on the bottom, y is always going up, and so whenever you write a chart or whenever you use a graph, you always put the x on the first part and the y on the second part because they make coordinates. And so back in the day in grade 7, you use coordinates, and if we look at these coordinates right here, you always start with the x value first, so that's 1, and then you move over to the side and to the y-axis, so that's 1 and 1. So that coordinate looks like this, if you remember. And if we go up to this dot here, it's 2 for the x, 2 for the y, so that would look like this, and so on, 3 and 3, 4 and 4, 5 and 5, so on and so on, all right? And so that just creates a line. If I zoom over to my other program, I just want to show you really what we're doing here. And we're going to be dealing a lot in graphs, so it's going to be a bit of a challenge in our online world, I suppose, but we're really going to do our best. All linear equations in this unit start with the letter y. So we always say y equals something. And so I'm just going to demo how everything's a straight line. 3x plus 6. There's your line. So pretty sweet, that's the red line. I can actually make another expression where I could go y equals, how about 2x minus 4. You'll notice that the line has a bit of a different slope, and so it intersects kind of down there. But they're all linear equations. If I make another expression, I could have y equals 12 plus 8. And let's see what, 12x plus 8, my bad. So let's do that, 12x plus 8. And again, you'll notice that this green line has a different slope. But all of these are linear equations. They're making straight lines on this graph, the x-axis and the y-axis. So super important for you to understand that every equation that we're going to look at in this particular unit should be starting with y equals. There should be a number in front of a variable, so like 2x, 3x, 12x, and then there's just a number there like minus 4, plus 6, or plus 8. And we're going to actually build these equations right now. So kind of zooming through that, we're going to look here, and it says a linear equation is an equation whose graph is a straight line. Well, I already showed you that, but what you're going to get is sort of some of these sample questions that have boxes or toothpicks or chairs at a table, and it's all about patterns. So this unit is all about figuring out what the equation is for the pattern, and then you need to know that every pattern is a straight line. Okay, so every pattern equals a straight line. And so that's what we're building here today. So what we have here is a pattern of little blocks, and we start off with 1 right here. And then in figure 2, we've got 4. little squares. It looks like in figure 3 we have 1, 2, 3, 4, 5, 6, 7 squares, and so on. And so I want you to recognize that there's a number of shapes here, and that's what we're looking at. So every single time in the first part of this unit, you guys, you're going to need to build this table. What's interesting about this is that in grade 9, we build this table. In grade 10, we look at things a little bit differently and we don't necessarily build a table, but this is about deriving a formula from a pattern. And so yes, this little convoluted, crazy table is something that I am requiring you to do in all of your homework and showing me that you understand how to build correct linear equations. So you're going to have to watch really carefully because at first it's going to look kind of weird, but we're going to do it 3 times in this unit. 3 times in this notes package here. So again, we're looking at these figures at the top, and we just want to make sure that you know that we're looking at figure 1, 2, and 3, and 4. And the first part of your table always has to have the figure numbers 1, 2, 3, and 4. Sometimes you have to name them, like the figure number 1, 2, 3, and 4. But and the minimal amount of figures that you always want to have in a little graph like this is 3. And the maximum I'm going to say is usually 4. Okay, you shouldn't have to go past 4, and you shouldn't go below 3 to be totally sure. So the next part of the table, it says, is number of squares. So then you go in and you go to figure number 1. So we go up to figure number 1 and we say, oh, there's 1 square there. So we write that in. Then go to figure number 2 and you count 1, 2, 3, 4, and you put a 4 there. Then you move to figure 3 and you count the squares 1, 2, 3, 4, 5, 6, 7, and we put that number there. And then we go to figure 4 and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's how we build the first part of our table. You always will have to put the figure number first right here. So this is the fig number, and then you're going to have to put the number of things that's there right beside it. I want to show you right now that when we built this table up here, this is representing the x and the y values. This is extremely important for you to know. So on the notes right now, I'm just going to write an x in the top of this table and a y in the top of this table right now because it will be important for you later. The next part of your table is the multiplying part of the table. And so that's why it says multiply by a number. And so right now, this is the pattern. So I'm going to just write up at the top, this is your pattern part of your table. So you have to be savvy and you got to go back up here and you got to look, what was my pattern? So I went from 1, I'm just going to write the numbers here, and then I had 4, then I had 7 and 10. So you actually need to be savvy. You need to figure out, okay, how did I get from 1 to 4? I added 3. How did I get from 4 to 7? Oh, I added 3. How do I get from 7 to 10? I added 3. So my pattern is plus 3. So you see that? So in this table right here where I wrote pattern, the multiply by plus 3, that's your pattern. So what you're going to do is you're going to have to multiply this table by all of the pattern numbers over here. So you'll notice I've done it for you right here. So I'm just going to walk you through. Pattern was 3 because we got it from looking at our squares. How many did they go up each time? Pattern number goes here. So then you multiply your pattern number to the figure number. So 1 times 3 is 3. That's how I got this answer in this block right here. Okay, this one here is 3 times 2. So that's why I wrote that right here. And so 3 times 2 is 6. That's how I got that answer right there. Then 3 times 3 is 9. And then your last pattern times the one down here is 4, which is 12. So that's how I built this section of my table. It's my pattern section. And I look at the figure number and multiply it by the pattern. Okay, super important. So just watching and learning. The last part of my table is what these little arrows are here, and I'm going to color them in green. So I'm just going to put the blue part of my table here. And so these blue arrows are reflected on the answers that I'm going to get in that little section right there. So the last part is, and I wrote in this is always going to be the same. You need to write in this little part of the table, add or subtract by something. So again, it's another pattern. So you ask yourself, how did I get from 3 to 1? Well, if I think about that, 3 minus 2 is 1. So that's that one right there, that blue there. 6 minus 2 happens to be 4. So that's good. 9 minus 2 happens to be 7. 12 minus 2 happens to be 10. So guess what? This number up here is minus 2. That's the new part of your equation. So what you're going to do now is to fill in the last part of your table. You're just going to go 3 minus 2 is 3 minus 2 is 1, 6 minus 2 is 4, 9 minus 2 is 7, and 12 minus 2 is 10. And what you need to notice here is that this part of the table and this part of the table are the same. And if you've done that right, then you are good to go and everything's good. So I'm just going to erase all of this gobbledygook here, and I just want to take a look at what we built. So that might have seemed really crazy, but I do want to just reflect on this part right here. You guys, what you did by finding the pattern number, the multiplier, and by finding this adding or subtracting number, you actually built a linear equation. Here's your equation right here. Y equals 3, everyone take a look. There's an x here. The 3 is the multiplier. It goes there. That's the pattern number, minus 2. So this graph, 3x minus 2, if we get rid of these, is this graph right here. Y equals 3x minus 2. Bam. That is what you just created. That's what you just figured out is the algebraic expression for this particular graph. Y equals 3x minus 2. It all comes down to these two parts of the table. These two parts of the table, this multiplies the pattern, okay, and it always sits beside the x. And then this part of the table right here is the answer, or which is called the constant, and so that goes right there. And this builds your nice little formula and equation. So for some of you, that's kind of crazy, and so it's all about practice, and it's all about figuring out what the heck's going on. Okay, so just to take a little side swipe over to this particular page of the notes, I just wanted to explain to you what the heck all this means. So 3n and then minus 2. Okay, so this is just a nice little equation here, okay? And so I just wanted you to see that whenever you have a number and a letter beside each other, that this number is the pattern number or the multiplier. And so then, and this is the figure number here, so multiply by the figure number, and so this is the minus or subtract number, which we said. Let's talk about what they're called. The numerical coefficient, that means the number in front of the letter, is 3. So if you ever get asked in your math pages, what is the numerical coefficient? Coefficient always means the number in front of the letter. So that's a 3. That's why I wrote 3 right there. Variable, well, we know that means letters, so that's the n right there. And the word constant means that it doesn't have a letter by it. So the constant is literally just minus 2, because if it had a letter beside it, it could change. Constants stay the same. But check this out. 3n can always change because n could equal 1, 2, 3, or 4. And when n equals 1, it looks like this. 3 times 1. 3 times 1 equals 3. So that's how this changes. 3 times 2 is 6. All of a sudden, this answer would become 6. 3 times 3 would be 9. So all of a sudden, this answer would become 9. And 3 times, so put the 4 here, would be 12. So you can see how these numbers change, but constants don't change. They just have a special number, and they don't have a variable. So you're going to see a lot of this in this unit where it tells you that the letter equals a certain number. So A tells you that n equals 12. All right, so what it's asking you to do is that when n equals 12, it wants you to put in the formula. So what you're going to do is you're going to go, so you're going to build a little formula here. And so here was the formula up here, 3n minus 2. So this is the formula right here, 3n minus 2. S equals 3n minus 2. So what you do is when it tells you that n equals 12, you stick it in right there. You stick it in where the n is. So it's telling you n is 12. Okay, I'll just put the 12 where the n is. So 3 times 12 minus 2. Awesome. So you just do the math now. So 3 times 12 is 36, minus 2 is 34. So the sides, or the squares, is 34. So what we just figured out here is when we said that n was 12, we were actually talking about the figure number. So when the figure number down here was 12, not 4, not 5, not 6, 7, 8, oops, that's brutal. Anyways, 8, 9, 10, 11, 12. Ain't nobody got time to build a table this long, right, guys? So what I did was, all I had to do was take my figure number 12, insert it into this position right here, and get my answer. If my diagram had 106 of these squares, it wants to know which figure number would it be. Okay, so right now, our max amount of squares in this is 10. We got to get 108. Ain't nobody got time to draw that many squares. So guys, guess what we do? We go ahead and we insert this into the S that stands for squares. So you'll notice that we took 106 and we put it underneath the spot that stands for squares. And then we just solve the equation. So 106 equals 3n minus 2. So we solve this beautifully, just like we've been doing in our math, and we get 108 equals 3n. And then you divide by 3, and so guess what, guys? N stands for the figure number, so guess what? Figure number 36, so here's 12, we're talking like all the way down to 36, there's going to be 106 squares. So this is how we use formulas to actually break the code on these little kind of diagrams and these patterns. All right, so we're going to go back to this pattern block here. And what I want you guys to do is, I know you probably don't necessarily want to draw all of the lines here, but I do need you to get a piece of paper and to work this out with me. If you don't work it out with me, you're not going to have a clue how to do this, and you're going to text me and you're going to message me and say, Duz, I don't know how to do this. And I'm going to say to you, did you pursue and watch this and do the math along with me while we were teaching? Because it's really the only way to actually get this chart in your mind. So make sure you have a piece of paper. I'm going to pause it now and draw this chart right here. Okay, so make sure that you draw this chart. On the top, you should have figure number, number of circles, multiply by, add or subtract by. And we're going to go ahead and work through this beautiful problem together, and you're going to have to solve it. Now, if you want to go at it at your own, go for it, but I'm going to do it right now so you can watch if you need to, but I want you to write stuff down while I'm going. So the first box here is the figure number. So pause it now and put in your figure numbers. You should be able to do that all by your big selves. So here we go. Figure 1, 2, 3, and 4. 1, 2, 3, 4. Great job. Easy peasy lemon squeezy. This part right here, number of circles, okay, is easy too. So you could pause it and count and write those in just so that you get the experience. There's 1 here. There's 3 in this one. There's 1, 2, 3, 4, 5 in this one. There's 1, 2, 3, 4, 5, 6, 7 in this one. Done. You're done half of the chart. Okay, the next part, if you recall, I called this the pattern. So now you have to find the pattern. And we're going 1 to 3, 3 to 5, 5 to 7. Guys, how did we get from 1 to 3? What number did we have to add or subtract? 2. 3 to 5, 2. 5 to 7, 2. Guess what the pattern is? Plus 2. Okay, so here's a time where it would be good for you to pause it and actually on your sheet of paper do this, because this is where it's easy to forget, what the heck do I do now? Well, I'll tell you, if you need my help before you get out of here and do it yourself, is you're going to take this pattern number and you're going to multiply it to all of these figure numbers right here. So go ahead and pause it and do it yourself now if you can. Otherwise, I'll do it right now. So like I said, I'm going to multiply this by this for the first one. 2 times 1 is 2. Then I'm going to multiply my pattern by my figure number. 2 times 2 is 4. Pattern by my finger number. 2 times 3, and I'll just show you what I'm doing, is 6. This was 2 times 2. This was 2 times 1. And the last one is 2 times right here 4, which happens to be 8. So here is your chart right there. The last part is trying to figure out how did we get back to these numbers right here? And we're going to have to add or subtract. So how did I get from 2 to 1? I minus 1. How did I get from 4 to 3? I minus 1. How did I get from 6 to 5? Minus 1. Looks like the pattern here is minus 1. So now, guys, what you're going to do is you're just going to go ahead and take this number right here. Sorry, so I'll just put it here. And you're going to subtract it by 1. So 2 minus 1 is 1. So I'll just write that right here in case you need to see it. 4 minus 1 right here is 3. This one, 6 minus 1 right here is 5. And this one, 8 minus 1 is 7. What you'll notice right away is that this and this are the same. That means you did it right. Last part, guys, is building your formula. So great job. Remember I told you up here that this is how you get your answer. Your multiplier and your adding and subtract numbers are your pattern. So here's the deal. This part gets the x. It's the multiplier. So your equation equals y equals 2x, because that's the 2 here, and then minus 1. Bam, you done. So good job. This is your linear equation. It's going to make a straight line, 2x minus 1. So if we go ahead and do that right now, just again to show you, because this is going to be important later, 2x minus 1, there you have it, and there's your graph. So now you can see that you have a beautiful graph just like that. Okay, awesome, good job. Okay. So now we're going to go to these like questions that I talked to you about before. And so the first thing you always got to do is you've always got to write down your formula. So guys, we wrote down our formula, y equals 2x minus 1. That's the formula right here. Okay, so I wanted to talk to you about these letters, x's and y's. I like to stay in x's and y's all the time, even if it gives me different letters, because I feel like my brain just gets it. Because remember I told you back at the beginning that this part right here is the x spot and this part right here is the y spot. When we go back to this chart way up here, looking at this, that's how you make coordinates on a graph, x then y. So just so that you do that, you'll never make a mistake if you look at it like this. How many circles are in figure 71? Okay, guys, check this out. The figure number right here refers to the x. So figure 71. This, guys, this figure number is the x value, so x equals 71. I want to know how many circles are in that little charty chart when we get to figure 71, which is out here. Ain't nobody got time to draw, like, I don't know, 60-some figures later. So all you got to do is insert the math. Since we know that this is the x, the figure number is x, we just are going to put 71 where the x was supposed to be in that nice little deal and subtract it by 1. So what you're going to do is we're going to go 2 times 71, which happens to equal 142 minus 1. 142 minus 1, last time I checked, is 141. So guess what? There are 141 circles in figure number 71. All right, cool. So let's go on to the next question. Again, you always want to write your formula first. So y equals 2x minus 1. Which figure number? Okay, look at it, guys. X is always the figure number. So we're trying to figure out which figure number has 83 circles. If I look on my graph, y is representing the circles here. Okay, cool beans. So let's do this. So this is my y and this is my x. I have 83 for my y. So right underneath the y, guys, you write 83 equals 2x minus 1. Solve this equation like a pro. Plus 1 plus 1. You got 84 on this side equals 2x. Divide by 2. Bam that out. X is going to equal, in the end, 42. So guess what? The figure number that has 83 circles in it, 83 of these, is figure number 42. So just that's how you figure that out. I wanted to come over here to the side note just because I think when I was making these notes, I was tutoring a grade 10 class on patterns and relations, and I just want to show you that there's actually like a special formula that you can use to derive these formulas without making this dumb chart. And you do it in grade 10 for just a little bit, but so this is the first number in your pattern. So like if we went up here, our first number in our pattern is 1. And then this is the number of terms minus 1 times the pattern number, which is there. And then in the long run, you actually can use this formula to build the linear equation, I guess we'll say it. Just so you know, so you're going to see this formula at one time. It's a little more complicated. We don't do it in grade 9. Anyway, so that's how you solve for when you have all that. So good job. Okay, so now guys, this is your time to actually figure this out. It's not hard if you have a piece of paper and a pencil in front of you and you're doing this on with me on your notes. If you're just going to watch, this is going to be a lot harder when you get to the questions in the textbook. But I just want to say for the record, pause it, do this question now. You'll be a genius if you do. So I'll read it to you. In a banquet hall, single rectangle table sits 6 people, but tables can be connected at end to end. 4 additional people can be seated in each additional table of the same size. So what's going to happen here is I want the linear equation. How many tables can be connected? So before you can answer any questions, you got to get the equation. So guys, draw your chart and fill in the tops just like I have up here. So we're looking at figure number of chairs this time, multiplier, and your adder or subtractor. So pause the video right now, try to fill in this chart all by yourself. If you can do it, awesome. If you can't, come back and take a look while I fill it out right now. So right away, I'm just going to put my figure number in first. Remember, that's our x. And then we're going to do chairs this time because that's what we're looking at. And so that's our y. I'm going to do this first before anything else. This is our multiplier. So that's our pattern. And this is our adding or subtracting. And so we'll just figure out what that is. And so, yeah, so let's try and go through this. Okay, remember I told you that it's probably best to have at least 3 figures. So we could draw the third figure here if we wanted to. It looks like you have 2 seats at every table, 1 at the end. So this would get 2, and then this would get 2, and this would get 1 here. So that's figure 3, and I'm just going to draw it in just for good times. 3 is always the best because then you know that the pattern is correct. All right, number of chairs in figure 1, let's count them. 1, 2, 3, 4, 5, 6 you should have had here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 you should have had here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 you should have had there. Okay, the next question is your pattern. So what was the pattern? So we've gone from 6 to 10 and 10 to 14. So what is the pattern? It looks like I can go plus 4 here and plus 4 here. So it looks like my multiplier is plus 4. That's my pattern number. Remember that you take this number and you multiply it to all the figure numbers. So the first one's going to be 4 times 1, which is 4 in the big blank. The next one's going to be 4 times 2, and so that's 8. And the next one's going to be 4 times 3, so that's 12. That's how you fill in your chart there. And then we need to actually go backwards. How did I get from 4 to 6? How did I get from 8 to 12? And how did I get from 12 to 14? Well, 4 plus 2 is 6, 8 plus 2 is 10, 12 plus 2 is 14. Whammo blammo, we got plus 2 in this box right here. So we do that to these numbers in here. So we go 4 plus 2, which is 6. We go 8 plus 2, which is 10. We go 12 plus 2, which is 14. We check to see that this is the same as this, and it is. So I have my formula now. My formula is derived from this number and this number. So my formula is y equals 4x plus 2, yes. So now, guys, I can figure out, and you can figure out now, if you can do this all by yourself, this will be great. But we can start to solve these questions. How many tables connected together will seat 26 people? I gotta write the formula first. It's always what we do. So we write the formula. I remember that my x is the figure number right here, and that my y is the chairs. How many, tables, I guess. So we're doing tables. So this wasn't chairs. This was tables, I guess. Oh no. You know what? I'm going to do... Can seat 26 people. Oh yeah, no, we're good to go. Oh, so the figure number, sorry, is the number of tables. Duh. So this is table 1. This is table 2. And this is table 3. Okay. So, sorry. So how many tables? So actually we're trying to figure out the figure number if it has 26 people or 26 chairs at it. So this is the y. So we just take this. We know it's the y. So we put 26 here equals 4x plus 2. We solve it like a pro. Minus 2 minus 2. 26 minus 2 is 24 equals 4x. We divide by 4. We divide by 4. X equals 6. So that means that there'd have to be 6 tables to seat 26 people. Okay, cool beans. Awesome. So looks like here I just gave another example, and I wanted you to actually just figure out how do you take this graph and or this chart here, sorry, this graph or this chart here, and turn it into an equation. So guys, in your notes, in your textbook, if they just give you this beautiful table right here, what I want you to know is that it's already half of this table right here. So it's the first part of it. So actually what you'd have to do, and I'm just going to write over everything because I don't feel like rewriting it, but you would have to go like this, okay, to be able to solve the equation. And you would, in your top part, this would be the multiplier. Okay, so I'm just making the table again. This is the plus or minus, and we'd have to actually just go through. So what is the pattern here? That's why I have these little arrows going like this. So what plus 13 is going to be 16? Looks like plus 3 here. This is plus 3, plus 3. So my multiplier is plus 3. Remember, guys, we multiply that to the figure numbers. So the first one's 0. The second one's 3 times 1, which is 3. Second one's 3 times 2, which is 6. 3 times 3, which is 9. 3 times 4, which is 12. I'm just building the formula here, guys. And then the next step was going backwards. How did I get from 0 to 13? How did I get from 3 to 16? 6 to 19? Guys, it's plus 13. So this is plus 13. And so you can check all of your answers. And so 0 plus 13 is this. And so I'd have all of these going down here. And so here's my formula in this little scribble. It's 3x plus 13. So that's how you get it from doing it from just a chart. But guys, what I want you to see right now is that here, this is graphed. And I wanted to go back to explain to you that you can use, and you need to use coordinates to actually build these graphs. That x and y matter, and that coordinates are like 0 and 5, or like 1 and 2, and that the x value is always first and that the y value is always second. So in this particular situation, even though you can't see my horrible graph, this is 0 and 13, so that's the first one. 1 is like 1 and 16, which is why that dot's there. And this one's 2 and 19, so if we go up, it should be close. And I mean, my graph sucks, but as you can see, you can actually make this chart from this beautiful graph, all right? So make sure that you are understanding that. So this is what I did here is I made my chart and I got my formula, and that's the same formula that we got up there. So guys, this is this particular unit, and this part I think is probably the hardest part to start with because it just involves you practicing a lot of things. So you're going to have your first textbook page, and make sure that you read my instructions because there's some hints on how to do them on the textbook page, because I often get questions in class and I'm putting the answers in the instructions, so don't not read them. So you can go ahead and pursue chapter 6.1, your first page, and the rest of the like 6.2, 6.3, they're pretty easy. 6.1 is the hardest, so it's going to take the most time, and it's going to probably have the most questions, but we'll do it at a live session. Hopefully you'll be great at it. Practice hard, and we'll just keep working through this unit as we go. So good job today, and I'll talk to you soon.